Let's go to page 483. This is lesson 7.7. This lesson is to solve right triangles. To solve a right triangle means to find a measure of all its sides and angles. You can solve a right triangle if you know either of the following. Okay, so two side lengths, one side length, and the measure of one acute angle. So basically, you need to have two information. Okay, so we need to have two information to solve for the right triangle. Okay, because again, right triangle you have one angle already, so you need to have two more information. So you need to get total of three information. Right, you got a right angle plus two other information to solve the right triangle. So again, to solve the right triangle means you're looking for angle A, angle B, angle C, and looking for side A, side B, side C. Okay, so here's a key concept. So inverse trigonometric ratio. So let angle A be acute angle. Okay, then inverse tangent. Inverse tangent means, see, normally you know the angle and you're looking for the length, right? But inverse function, inverse tangent is to find the angle. So whenever you see the inverse, or like this is not a -1 power, okay? This is the inverse function because this is the -1 is the superscript for the function. So this is the inverse function, okay? So this is inverse tangent. So when you see that, right away, that is an angle, okay? Again, inverse function is an angle. So this is the inverse sine, inverse cosine, okay? So again, inverse function is an angle. Inverse is an angle. Inverse. So as soon as it's inverse, you have to think about angle. Okay, so let's go over how to find an angle measure. Okay. So use a calculator to approximate the measure of angle A to the nearest tenth of the degree. Okay, so here's your angle A, and the two sides involved are here and here. So here's your angle A. So this is opposite and adjacent. Okay, so first you want to write your function. Okay, so let's see how to do this kind of problem. Okay, so on page 483, okay, you have this triangle. So it's A, B, C, 15, and 20. Okay, so this is the angle that you're looking for. Okay, so by looking at that, this is opposite of adjacent, so that is your tangent function. Okay, so tangent A equal to the opposite over adjacent. Okay, so tangent A equal to 15 over 20. So tangent A equal to, well, this is equal to 3 over 4. Okay, so to find the angle, you have to remember so angle A. Okay, let's do this. Okay, so angle A will equal to. Okay, so to find the angle, okay, find the ratio, you have to use a second function. Okay, so you have to use, see over here, this is going forward. This is when you have the angle, but when you're looking, this is when you have the angle and you're looking for the side. But whenever you're looking for angle, you have to use this over here. That's the inverse function right here. Okay, so that's your inverse function. See the tangent superscript -1. Yeah, that's your inverse function. So whenever you're going to look for a second inverse function, you have to use second button. So you go second tangent. See that? That's how you get the inverse tangent. So to find the angle, you have to use the inverse function. And you enter the 3 over 4. So 3 over 4. Again, make sure you close parentheses and equal. And so this will give you 36.869 whatever. Okay? And so this will approximately equal to, let's see, to the nearest tenth of a degree. So nearest tenth of a degree will be 36.9 degrees. Okay? So make sure you follow the instruction about how far to run these things. Okay, let's go to, so this is example 1. Okay, now let's go to page 484. Okay, let's go to example 2. Okay, it says the angle A and angle B be acute angles in two right triangle. You should calculate the approximation of angle A and angle B to the nearest tenth of the degree. Okay, so A, you have sine A equal to 0.87. B, you have cosine B equal to 0.15. Okay, so again, to do that, you just go, since you're looking for angle, you have to go second function, right? So go second, and this is sine, so second sine. Okay, so that's your inverse sine. And you enter 0.87, closing parentheses, equal, and to the nearest tenth of degree. So nearest tenth should be 60 degrees. Okay? Nearest tenth, okay, 60.5. Nearest tenth, okay, yeah, make sure you follow the instructions. 60.5 degrees. Okay, now to find the angle B, so it would be, to be more exact, you have to measure the angle. Okay, so, but normally you kind of just drop that, okay, because it's kind of, most of the people are kind of lazy, so they kind of drop that. Technically, you need to have M, angle B, but you know, normally we just kind of drop that. We just say angle B equal. But to be technically correct, you need to have a measure of angle B. Okay, but from now on, if you don't have that, that's fine. Okay. Okay. Anyway, so you're going to go second cosine of 0.15, closing parentheses, equal. So this would be 81.4 degrees. Okay, and that's it. Okay, now let's go to example 3 to solve a right triangle. So I'm going to draw a picture right over here because I'm going to do a lot of writing over here. So this is a good practice to keep you organized. As soon as you see the word solve the right triangle, right away you're going to go A, B, C, A, B, C. So capital letter, this is an angle A, angle B, angle C. This is a side A, side B, side C. Okay? So that way you can keep track of what you have and what are you missing. Okay? Okay, so over here they have A, B, C, and this is 42 degrees and 70 feet. Okay, so again, remember, this is angle C, so this would be a small c. This is angle B, so this would be a small b. This is angle A, so this would be a small a, right? They're always facing each other. Okay, so that's going to put down what we have. So angle C is 90 degrees, so we know that. Okay, angle A is 42 degrees, okay, and small b is 70 feet. Okay. Now remember, the three angle equal to 180, so this is already 90, so this would be complementary angle, so this is equal to 90. So 90 minus 42 will give you 48 degrees, because they have to add up equal to 90. So right away you know that, right? Okay, so now we're going to look for A, okay? So, so to look for this, so let's see. So this is 48 degrees. Okay, so since this is given, so you have to use this. So looking for A, so this would be, so I'm going to use this angle, okay, because I like to use the base angle. I don't like the angle up there. So I'm going to use this angle. So the ratio of this would be, so this over this would be tangent, right? Because there's two sides. So write down tangent of 48 degrees equal to 70 over A, right? So tangent equal to opposite over adjacent. Okay, so that's that. So cross multiply. Okay, there are many ways you can solve these. You don't have to use 40. You can use 42. In this case, it would be actually a bit easier. Okay. And then you divide. So A equal to 70 divided by tangent of 48 degrees. Okay. So get your calculator. Okay. So 70 divided by tangent of 48 degrees equal, so A equal to 63. How many do they run it off to? One decimal answer to the nearest tenth. Okay, so it'd be 63.0 feet. So that's A, so it'd be 63.0 feet. So because even it's a 0, but you still want to, to the nearest tenth, right? That's what they want. So got extra 0 in there. Okay. Now let's go to C. So then C. Now once you get this, you can use Pythagorean theorem. You can have A squared plus B squared equal to C squared. Okay, you can do that. But since we try to practice with trigonometric ratio, so let's go and not use that. Let's go and use this. Okay, that's equal to 63. But this is already kind of approximate. So we're going to use this too. You try to use the giving that's exact as much as possible. Okay, so this would be sine function. Okay, so sine of 48 degrees. So sine is opposite of a hypotenuse, so equal to 70 over c. Okay, so cross multiply, divide. Okay, so let's go and use calculator. Again, make sure you write down all the steps. Okay, so 70 divided by sine of 48 degrees equal, so C equal to 94.2 feet. Okay, so you put over here, so 94.2 feet. Okay, and that's it. So make sure you do this right away. So this will help to keep track of what you have and what you don't have. Okay, so this will help you to keep things organized. Also, it helps you to decide what function to use. So this is a very useful, method. Okay, let's go to example 4. So again, this is very important. Make sure you get into a habit of doing this. Whenever you see the word solve, triangle, okay, you go ABC, ABC. Okay, that will help you to keep things organized, and that's confusing. Okay. Okay, example 4. Okay, theater design. So again, you can read through. So that gives you this picture right over here. Okay, so here's your X degree, and here's your stage, and this is 2 feet, and this is 30 feet. And what I'm looking for. Okay, suppose your school is building a raked stage. The stage will be 30 feet long from the front to back with a total rise of 2 feet. Okay, a rake, or the angle of elevation, is of 5 degrees or less is generally preferred for safety and comfort of the actors. Is the rake stage you're building within the range suggested? So basically looking for this angle. Okay? So this is opposite of a hypotenuse. So this one has to use sine function. So you're going to get sine of x equal to opposite of a hypotenuse, equal to 2 over 30. Okay? Okay, so to find the angle, so measure of angle x. Now, if you don't have a measure, if it's just the angle x, that's fine. Okay? Normally, we start to get lazy, we just say angle x. But technically, you need to have a measure of angle x. Okay, so again, to find the angle, you also have to use secant function, right? So you're going to go secant sine, okay? That's your inverse sine. Again, whenever you're looking for angle, you have to use inverse function of 2 over 30, so 2 over 30, okay? Closing parentheses, push equal. So you got 3.8 degrees. They run it off to 3.82. So the answer is slightly up, but that's okay. Okay, because they run it off and they run it off again. That's why the answer is different from these. This one just goes straight. Okay, so it'd be 8.2. 8.2 is fine. Okay, so this is acceptable because this is less than 5 degrees. Okay, so the answer is yes, is within suggested range. So yes, this is safe. Okay, and don't forget, you got to have that. Very important. If you don't have that, means it's radian. Radian and degrees are very different. Just like feet and meters are very different. So if you don't have that, then answer is you could consider wrong. Okay, you must have a degree because 1 radian, okay, is approximately equal to 57 degrees. Okay, so if you don't have that, you're going to be off by a factor about, like 57. So if you don't have that, that means this is going to be about 200 degrees. Okay, this will be close to 200 degrees. Okay, if you, let's see, so 3.8 times 57, yeah, about 220 degrees. So if you don't have that, this would be about equal to about 220 degrees. So make a big difference. Again, 1 radian is approximately equal to 57 degrees, somewhere around there. Okay, so just be aware of that. So make sure you have the degree. If you don't have that, means radian means totally something different. Okay, so that's very important to remember.